video I'll be demonstrating the Python Tesseract API. Tesseract is an open source software for OCR, or optical character recognition. On some of my previous videos, people have been asking about character, word, and text recognition. If you are looking for something like that, Tesseract would be a great option. To demonstrate, I've written code to interpret and display results from images of Acula COVID-19 test cartridges. As you can see here, I have 3 different images. The cartridge consists of an ID, a date, and a blue bar indicating the result of the test. In this image I have a negative test. In this image I have an inconclusive test. And in this image I have a positive test. Now, to the Tesseract installation process. To install the Tesseract Python wrapper, it only takes a few commands. I'll be installing it in an Anaconda virtual environment, but you can use a standard command prompt as well. Virtual environments are used to avoid version conflicts. If you want to install Anaconda, I'll leave the link in the description. To create the virtual environment, just use conda create -n. Let's call it Tesseract. Python equals 3.8. Now, to install Tesseract, we can just use pip install pytesseract. I'm also going to be installing OpenCV, as I feel it's essential in most computer vision projects. We can do this with pip install OpenCV Python. Once this is finished, we're all set. We're now ready to run OCR. Before we do so, I'd like to briefly walk you through my program. I have included the program as well as my test images in my GitHub repository for Tesseract OCR, link in the description if you want to take a look. The program takes 2 inputs, the image and the confidence threshold for detections. In using OpenCV, the image is converted to grayscale as I found it to improve accuracy. This is purely for inference. The output image retains color. The program then cycles through all the detections looking for 3 patterns. The date in the form year, month, day, the 9-digit ID consisting of capital letters and numbers, and also the result identifiers, as you can see in the image, which are C, T, and NC. If the detection meets a condition, it's annotated via bounding box and they're printed in the console. To determine the result, the program scans the area to the right of each identifier. If the area is blue, then the result can be derived. Now, let's see it in action. In the console, you can see the test ID, you can see the date of the test, and in the image, you can see the ID as well here, and the date of the test annotated. Here you can also see all the result identifiers annotated with the bounding box. And in this image, it says that the test is negative. As you can see here, the test is negative. For this demo, I use a Tesseract pre-trained model, but you can train your own from a custom dataset as well. This can improve accuracy significantly. During testing and refining, I had to increase the size of the text, or it wasn't even detected. Even now, the program doesn't interpret the text entirely properly. If anyone wants a tutorial on how to train a custom model, I'd be happy to post another video on the topic. There's still a lot to improve upon, so until next time, bye.